This question comes from David. What would happen if you tried to funnel Niagara Falls through a straw? Short answer, you'd have a lot of conversations with the International Niagara Committee, the International Niagara Board of Control, the International Joint Commission, the International Niagara Board Working Committee, and probably the Great Lakes St. Lawrence River Adaptive Management Committee. Also, the Earth would be destroyed. Well, that last part isn't quite right. The real answer is, Niagara Falls wouldn't fit through a straw. If you tried to force it, say by building a dam across the falls with a single straw-sized opening, a tiny trickle of Niagara would squeak through the straw, while the rest of the water piled up behind the dam until it overflowed. There are limits to how fast you can push fluids through a small opening. Pushing fluid from a wide channel into a narrower one speeds it up, but only to a point. Eventually the flow chokes. Water tends to boil if the pressure around it drops. When a fluid accelerates through a constriction, the pressure inside drops invariably and without enough pressure to keep water from boiling. Steam bubbles form a process called cavitation. Paradoxically, cranking up the pressure to force more water through only makes it boil faster. Cavitation limits how much water can pass and also damages pipes. When those vapor bubbles collapse, they implode and erode the pipe walls, leading to structural failure. A rough calculation suggests Niagara's flow at the base could only be funneled into a pipe as small as roughly 10 meters across before cavitation becomes likely. Another limit is the speed of sound in the fluid. You can use pressure to accelerate a fluid toward its sonic limit, but water's speed of sound is very high, and if you try to push heavy water that fast, it stops following the pipe's turns. How fast would Niagara have to go to fit through a straw? That's easy to estimate. Divide the fall's flow rate by the straw's cross-sectional area. The legally mandated flow over Niagara is at least 100 seconds. At that point, cavitation is irrelevant. Everything's a plasma, and normal boiling concepts break down. The water molecules would be shoved into extreme energies, and no machine could realistically accelerate such a bulk flow to relativistic speeds. Particle accelerators can reach relativistic velocities, but they're fed by tiny gas sources, not Niagara Falls. If you could somehow accelerate that much water to relativistic speeds, the resulting particle jet's power would exceed the power of all sunlight falling on Earth. Your straw waterfall would become a small star, radiating so much heat and light that it would vaporize the oceans and render the planet uninhabitable. In short, you'd be in very, very big trouble with the International Niagara Committee, and with physics.